Hello, my name is Alexis Iaryczower, and my project 2 for design and manufacturing is on additive manufacturing. I will be going over the fundamentals, applications, trends, and future opportunities, technological innovations, and skills required to be an expert at additive manufacturing. So, for an introduction, what is additive manufacturing? It's basically a fancy way of saying 3D printing, which means you're getting a computer-aided design part from a file and transforming it into a real-life 3D object. These objects are printed in layers, which you can see here in the picture of a 3D printed boat, all the small layers that make up the object. And since you are printing only the material that is going to be used for the object, this process uses less material and there's less material waste than other manufacturing methods. The most common forms are plastics and metals, but recent trends and future opportunities show the potential for biomaterials and food to be printed with 3D printers. Now to go over some of the fundamentals of additive manufacturing. So here are some of the most common processes used in additive manufacturing. The first is deposition modeling. This is probably the one that you're most likely to have already seen, and it is where plastic is forced through a heated print head. The next is stereolithography, which is where a vat of resin is solidified through photopolymerization. Basically, the platform will lower as each layer is formed on top. The layers in this process are formed through photopolymerization. This process is better for more detailed parts, but does not create very strong parts. The next is selective laser sintering. In this process, laser sinters particles of polymer powder together. So it is formed, as you can see in the photo here, from that white powder. And this has some limitations for designing because there has to be an outlet for the excess powder to be removed. Finally, in multi-jet fusion, layers of powder are laid and then a fusion agent and detailing agent is added on top and with heat. This process is very powerful and creates strong and detailed parts, as well as creating them faster than other methods. Next, I'll discuss the applications of additive manufacturing. So this type of manufacturing has a wide variety of applications in different industries. Some of these include dental. Additive manufacturing can be used to create crowns, models, retainers, and dentures from very accurate and detailed models of patients' mouths. Similarly, it can be used in the medical industry. It can be used to make insoles, lattice casts, which were shown in this slide before, and are a much more breathable and material effective way of making casts. They can also be used to make medical pillows and braces that can more easily conform to the patient's body. Along the same vein, it can be used for footwear to make custom shoes, custom soles, custom designs, and different orthopedic shoes. There are also many different applications in the aerospace industry. Additive manufacturing can be used to make more lightweight components. It is also easier to make parts with more complex geometries using additive manufacturing. It is also easier to have faster prototyping with this because you can simply print out a new part and test it that way instead of having to go through the whole process of manufacturing the real part. And it can also be used to actually manufacture tools and different things for astronauts in space. It can also be used in energy to make turbine nozzles, perforated pup joints, and different sealing accessories. For the automotive industry, it can be used to make engine manifolds, gear shift knobs, and air conditioning vents. It can also be used for different consumer goods, such as mascara wands, eyewear, jewelry, bike saddles, you name it. There are plenty of other industries that can benefit from this. There are technologies to 3D print houses using cement. There's plenty of applications in defense for customized tools and weapons. Lab meat will use additive manufacturing to print the different layers of tissue in the fake meat. And the possibilities for custom athletic equipment are also very vast. Next up are trends and future opportunities. Some examples of recent trends include novel materials. This includes 3D printing with ceramics, biomaterials, and composites. Another popular area of research for this is high volume production. Additive manufacturing can be great for making super detailed parts, but is not the most efficient manufacturing process. Another trend is advanced printers. This includes things like bioprinting, which allows organs to be printed and transplanted, as well as simple things like having a reduced energy consumption in the machine. Similarly, there are a lot of technological innovations in this industry. The main one of these being the impact of artificial intelligence on additive manufacturing. AI can be used as a means of quality control. AI can ensure a higher quality with fewer errors. This can be through things like spaghetti detection, where the computer can detect when the filament is not adhering to the surface. And AI can make real-time adjustments to the parts to ensure that every layer is being printed properly. AI can also increase the accessibility of additive manufacturing. There are various skills required to design 3D printed parts and to actually print them, which I will go over later. But using AI, it means that more people who don't have as much expertise in these skills can make 3D printed parts. This means that AI can help to aid someone while manufacturing the part with additive manufacturing, and can use generative design to create parts that are suitable for additive manufacturing. The third innovation is Design for Manufacturing Copilot. This means that while you're designing the part, you can make sure that it's optimal for printing. It can be sure to minimize shrinkage of parts or other defects that might occur when the part prints. It can also make sure that there's material efficiency, that you're using the least amount of material possible. And again, can make sure that there's no weak points in the geometry. Our final topic is the skills required to be an expert at additive manufacturing. The most important of these skills is going to be knowing CAD. Again, this is computer-aided design. Some popular softwares for this are AutoCAD, SolidWorks, Blender, but there's many out there. And being proficient in one or more of these softwares will allow you to design parts that can be printed. The next is going to be design thinking. This is going to be, again, more of this engineering technical knowledge. You need to understand how additive manufacturing works, which process you're using, so you can make sure that your design isn't going to fail or break or have any sort of defects when it prints. It's also helpful to know about different materials, which materials will be suitable for the part you're designing, and have knowledge of complex geometries, being able to understand the angles and shapes that things are making in your part. Another important place to have skill and knowledge is finishing. This could include things such as sanding, cutting, and polishing. When your part comes off the printer, it might not be exactly the way that it needs to be for the prototype or whatever you're using it for. So you need to be able to edit it after it comes off the printer. Of course, safety is also going to be a big factor. You're going to want to make sure you have proper fire safety, and waste management is also going to be big here. Reverse engineering is also going to be important for this industry because you need to reimagine obsolete parts, because the design freedom that additive manufacturing gives you will help a lot for this process. Finally, problem solving is also going to be crucial here. You need critical thinking skills and creativity to be able to design effective and unique parts. There are many different possibilities and benefits to additive manufacturing.